How do you prove a unified theory of physics if its core mathematical parameter is entirely invisible to our instruments? This is the challenge facing the observer-dependent theory of everything, or ODTOE. The theory relies on a metric called coherence, represented by the letter S. Coherence dictates the exact point where quantum probability collapses into classical, rigid reality. Prior to recent work by researcher Anton S. Pankrotov, calculating coherence required a highly specific input. The formula demanded the individual contexts, the internal beliefs, of every interacting part within a system. While we can survey a group of people to map their collective agreement, we cannot interview a subatomic particle. This measurement barrier left the theory in a state of limbo. Without a way to read the coherence of microscopic systems, the math remained unfalsifiable. A theoretical framework can be elegant on paper, but to qualify as physics, it must anchor itself to data we can actively measure. Pankrotov published a solution to this deadlock. He utilized the Hurst exponent of fractional Brownian motion to link abstract coherence to physical particle movement. The mechanism relies on anomalous-diffusion, a standard property in condensed matter physics that tracks how matter spreads outward over time. It is denoted by the Greek letter alpha. The relationship reduces to a straightforward identity. Coherence equals the anomalous-diffusion exponent minus 1. Normal diffusion, purely random movement, carries an alpha of 1, resulting in 0 coherence. Ballistic transport, particles moving in absolute unison, yields an alpha of 2, outputting maximum coherence of 1. By tying coherence to physical diffusion, the theory's central variable becomes a hard, measurable number. Biologists and physicists have been recording the diffusion exponent in laboratories for decades, entirely unaware that they were also tracking coherence. There are vast public datasets documenting the physical spread of plasma ions, the movement of proteins inside cells, and the migration patterns of amoebas. Pankrotov took his formula and applied it retrospectively to this existing literature. By taking the recorded alpha values from these experiments and subtracting 1, he extracted the coherence levels of these real-world systems. The paper also proposes a direct cross-validation experiment. Researchers can calculate the internal coherence of a group of humans using questionnaires and simultaneously track the physical diffusion of their group movements. If the theory holds, both methods will yield the exact same value. Tracking the microscopic jitter of physical matter now serves as a universal thermometer for the quantum state of any system. Because coherence can now be measured via diffusion, it can be plugged back into the broader predictions of the ODTOE framework, including the formula for the Planck constant. Substituting alpha into the ODTOE framework defines the Planck constant as a function of the medium's diffusion. This chart maps the relationship. As the surrounding environment becomes more coherent, approaching an alpha of 2, the effective quantum of action climbs exponentially. There is a perfect environment to physically test this prediction, a Bose-Einstein condensate, created by cooling a cloud of atoms to near absolute zero. In this extreme state, the atomic cloud moves ballistically. The mathematical prediction is strict. The effective Planck constant measured inside this condensate will be demonstrably larger than the constant found in a thermal cloud. The observation grain expands and contracts based on the measurable harmony of the space it occupies. This mathematics addresses a fundamental macroscopic question. Why do subatomic interactions appear reversible, while the wider universe only ages forward? The framework introduces a parameter called R. It is a mathematical ratio that defines the battle occurring within any system between directed drift and random stochastic noise. Directed drift is the manifestation of the arrow of time, while stochastic noise serves to mask it. At the scale of a single atom, the strength of the time arrow is just 2%. Random noise completely overpowers the drift. Because the forward direction is mathematically buried, the equations of quantum mechanics can run backward without conflict. But as observation scales up the hierarchy of mass, the parameter shifts. The math proves that as you combine matter into larger structures, the strength of the drift exponentially multiplies, suppressing the random noise. The relentless forward march of time is an emergent victory. Coherent, macroscopic scale simply outperforms random, microscopic chaos. This raises a final, critical limit. At what exact scale does the physical drift completely overwhelm the noise? locking the arrow of time into an absolute, irreversible law. By setting the parameter to the exact point where drift balances against stochasticity, Pankratof's formula calculates a critical dimensionality limit. The calculation strictly outputs a dimensional level of roughly 8.12. In the ODTOE hierarchy, this number maps to the scale of the metagalaxy, the massive, interconnected structure of the cosmos itself. At this exact scale, the math shows drift in total control. The arrow of time permanently locks, driving the irreversible expansion of the universe. For humans, the mathematical arrow sits at roughly 9%. This intermediate state is strong enough to enforce the boundary between the past and the future, but weak enough to permit conscious memory and reflection. Microscale particle jitter and macroscale galactic rotation simply exist as two vastly different points along the exact same continuous mathematical spectrum of coherence. The destiny of the universe, the flexibility of the quantum realm, and the direction of time itself are mathematically connected, and we can read them in the simple, measurable diffusion of a wandering particle.